Very good afternoon to one and all present here. Myself T. Prem Kumar, Assistant Professor at Department of Computer Science. Today I am going to take a topic on a blockchain which covers the primitive design of a blockchain, architecture as well as the cryptographic primitives. So what is meant by the blockchain generally? I want to tell you about that. So blockchain is one of the mechanisms which is used to secure our data, and we cannot able to alter once it has been added into the network. That is the general information about a blockchain. So we will see about the design primitives of the blockchain. So the blockchain systems are built on the several fundamental designs primitives that defines how the data is stored, shared and valued among the various participants. The next, these primitives ensures that the systems is secure as well as the decentralized, fault tolerance and trustworthy. So the essential design primitives includes such as protocols, securities, consensus mechanisms, permissions and the privacies. When you talk about the first, the protocol we know it is a set of rules which has the foundational rules and procedures that governs how the blockchain nodes communicates and operates. And followed by that, the key elements which has inside these protocols are, one is the communication protocols which specifies how the nodes exchange the blocks and the transactions along with its updates. The next one, the transaction protocol. This defines the structure of a block as well as the validation rules, digital signatures and the other formats. And for block formation rules, it says about how you going to transactions are made, and it has been made in a group, as well as how the blocks are created and linked as well as and its time stamped. Though the next element is the governance rules. So it is going to determine how you going to upload are forks and managed. This is what the key elements which you have it in the protocols. Then come to the next one, the security. The security is one of the most wide feature in this blockchain networks, which is going to ensure the data cannot be altered at any case, and it has been forged or accessed by the unauthorized parties. So next, the major securities mechanism which under this is, one is the cryptographic hash functions and the digital signature. Next is the public key cryptographic and the Merkle tree. The last one is immutable ledgers. When we talk about the cryptographic hash functions, it provides the immutability and the tempo detections. In the case of digital signature, which ensures the authentication and the non-repudiations of the transactions. Then the third one, the public key cryptography, which securely identify the users and verify how the actions is going to be taken over there. And the Merkle tree is one of another important features in it, which is going to be utilized for the efficiently verifying the large data sets transactions. And the next one, the immutable ledger. So once the ledger has been created in a blockchain networks, at any cost we cannot able to prevent the unauthorized modification of any historical records. When you come to the threat protections, the security primitives protects against the double spending, tampering with blocks, unauthorized access and the repaying attacks. The last one is cyclic attacks, which is nothing but the combination of the consensus mechanisms. So these are all the threats we have in the case of the blockchains. Then the third one, that is the consensus mechanisms. These mechanisms allows the nodes to distributed environment to agree on the current state of the ledger. The functions of the consensus are, it is going to ensure all the nodes have a single version of truth, and it prevents the malicious nodes from the altering data. And the next one is the coordinating blocks, creations and the validations. So this is the functionalities of your consensus mechanisms. When you come to the common algorithm, which is and the consensus mechanisms are, one is the POW, that we call it as a proof of work, and the next one is the proof of stake, and the next one is delegated proof of stakes, that is DPoS, and the fourth one is PBFT, that is practical bicentennial fault tolerance mechanism, and the last one is the proof of authority, POA. So the fourth one is the permissions. When you talk about the permissions, the permission determines who can participate in the blockchain and what level of an access they have, what level of access they can have. So there are two types of permissions we have in the case of blockchain. One is
that is permissionless, we call it as a public blockchain. The other one is permissioned, which is a private or as well as the consortium blockchain. So when you talk about the permissionless blockchain, anyone can access, they can join, they can read, they can write, as well as they can validate, which is an example for that is Bitcoin as well as the Ethereum data, and which is highly decentralized but has a lower scalability. But it is being compared with the
permissioned blockchain, so only the authorized participants can able to read as well as the write, who can have a read as well as the write actions. The next one, which is used to for the enterprise as well as the government sectors, and which has the better control, security as well as the performance. So the last one is for this privacy design primitives is the privacy. So the privacy ensures that the sensitive data is protected even though the blockchain is transparent. Then when we talk about the privacy concerns, the public blockchain exposes all the transaction details, and which is going to enterprise the applications required the confidentiality for the users or the business data. This is what the privacy concerns. When you talk about the privacy techniques, there are several techniques is going to be applied. One is the encryption, which is for the sensitive information. We have this cryptographic concepts, and the next one, the pseudo anonymity using public key cryptographic system, and the zero knowledge proofing to validate the transactions without revealing the data. And the next one is the secure the multi-part computations, and the last one is the channels and the private data collections, where there's an example for that is Hyperledger, that is Hyperledger fabric. So the differences between the transparency and the privacy, which has been balanced in the blockchains, this design must have the balance, openness, that is auditability, and the confidentiality. So especially in the finance, the healthcare, and the government applications, it is going to be very transparent as well as the privacy. Then we see about the blockchain architecture and the design. When you talk about the blockchain architecture and the design, the blockchain is a distributed, decentralized ledger system in which the data is being stored in the form of a chained blocks, which is going to be formed in the form of a chained blocks. Its architecture ensures the security, the transparency, immutability, and the trust without relying on any central authorities. Then we have a basic architecture of the block diagram of this blockchain is the blockchain architecture consists of several layers as well as the components. The major components that are, the one is the block structure. This block structure is going to have three parts in it. The first one is the block header, and the second one is transaction, and the third one is the block header. When you talk about the block header, we have some information element which have inside in it. One is the previous block header. So whenever you are going to enter into the network, so once the block has been created, it will also point to the previous one. So that once the data is going to be added into the network, so you will be also comes into the chain. So that is what the previous blockchain. And the second one is Merkle root, which is for the hash of all the transactions. Then the third one is timestamp. So at what time it has been created, and the nuance is going to be the times, how much time it has been taken to exchanging the data or the transactions will be carried out. The last one is the difficulty level. So these are all the first part we have in the case of the block header. When you take the transaction, a list of several transactions as well as the functions is going to be executed in this transaction section. And the third one is transaction, the third one is the block hash. It is a unique identifier generated by the hashing of the block headers. Then see, the second part of the architecture is the blockchain as a chain of blocks. So we know we are saying it is a blockchain. So whatever the block it has been entered into the network, it is being like connecting towards with each others, right? So that is what we are saying. So each block is being connected with the previous blocks. So that is what each block points to each predecessors via the hashes and forming a tamper resistant chain. Okay, so that is the block 1. We call it as a hash block 0, and this is block 2 is called as a hash B1. And we can also say the block 3 is also a hash, but it has been identified with a unique name, that is B2. So similarly, we will be having number of blocks of data. Okay. So any changes in the earlier blocks brings its subsequent hashes. If suppose we are going to make any changes in the block 3, the 3 is also there, and it is also going to be carried out in another block. So even a single point of changes has been occurred in any block, that is going to be considered as another block. So we cannot able to make any changes in the existing blocks. That is what the major advantages in the case of the blockchain network. So next we will see about the network architecture. When you talk about the network architecture, the blockchain networks can be of, one is the public as well as the permissionless blockchain. That is, anyone can join, validate, and they can read. Like a example, we can say it is an Ethereum as well as the Bitcoin. The second one is the permission blockchain. Only the authorized participants can able to access, which has been seen in the place of Hyperledger Fabric as well as the Corda. And the next one is the consortium mechanism blockchain, which is managed by the group of organization, like the example large sectors like banking corporations. Okay, and the next is the key components of the blockchain design. So what are the key components we have is, one is the nodes, the device participating in the network. So any other node is going to take part in the chain, we call it as a node. So devices participating in the network. So what are the types of nodes we can have? One is full node that stores the complete ledgers about the data. Okay, that is the full node. And the light node is nothing but stores only the partial of data. And the third one is minus as well as the validated node, which has very less number of data. Okay, so these are the types of nodes we can say in the case of the network. Then the next one is distributed ledger. This distributed ledger is going to tell you about the synchronized copy of the blockchain, and is stored across all the nodes. We know the blockchain, the data will not have a centralized console. The data is not going to store it in a centralized, it is going to be stored in distributed manner. So that is what the synchronized copy of a blockchain is stored across all the nodes. And the third one we have, that is cryptography. This cryptography will have the mechanisms to provide the privacy as well as the protection mechanisms, like applying the hashing techniques as well as the digital signatures and the Merkle tree secures, which is going to secure your ledger. Then you come to the smart contracts. When you take the smart contracts, the self-executing programs are on the every ledgers. Okay. For example, when you take a contract that releases the payment automatically after verifying the delivery in the supply chains. So once the data has been delivered, then automatically the amount is going to be delivered, the payment method is going to be processed. So this is what we saw say in the case of a smart contract. The next one is the consensus mechanism. This algorithm that ensures all the nodes which is going to be agree on the transactions validity. Okay, so whenever any transaction is going to be takes place, the node is going to agree these transactions. That is going to be carried out in the case of your consensus mechanism. The example for that is POW and POS, and that is PPFT, that is Byzantine fault tolerance mechanisms. Okay, the next one, the transaction flows in the blockchain. That is, so in this, the diagram, that is, the flow is going to be explained. That is, from the user, it is going to be sent into the submit transactions. From there, once the transaction is submitted, it is going to be validated. Once it has been validated, the data is going to be added to a block, and that block is going to be sent with some consensus mechanism, and then the block is once the block is been completed, the block is going to be added to the chain, and then finally the network is going to be synchronized. So these are the steps we are going to be followed. See, and outside I am going to tell you that the transactions creations, once the user is going to make some changes, going to do some transactions, first the transaction is going to be created. Once the creation has been over, then the transaction broadcast to the network is going to be takes place, and thereafter the data is going to be validated by the node side. Once the nodes is identified or validates the data, then it has been grouped into the blocks, and those blocks is going to be go for the determination of your consortium mechanism, whether the block has any privacy security mechanism is there. And next one is the block added to the blockchain. Now once it has been verified everything, after the consensus mechanism, the block is going to be added into the network, and finally the ledger updated across all the nodes. So once any data has been added into the network, that the data's information is going to be distributed to all the other networks all the nodes in the network. Then we take an example for the blockchain architecture. We have a Bitcoin architecture, we have public blockchain, proof of consensus mechanism, no smart contracts mechanism, and UTXO models has been applied in the case of Bitcoin and the architecture. And when you take an Ethereum architecture, we have a public blockchain and smart contracts and account-based models, and the next one is POS, that is proof of stake consensus, that is called as a post-merge.
And the next one is the Hyperledger Fabric architecture, which is the permissioned, that is, you can only the authorized or corporates as well as any private organizations is going to have this kind of the Hyperledger architecture. So which is pluggable consensus and which is uses the chain codes and also the private channels for the confidentiality. This is what the architecture. And the last point we are going to see, that is the design principles of the blockchain architecture. When you take a design principle of an architecture, we have decentralization mechanism. Blockchain is one of the most point we need to discuss over, that is a decentralized mechanisms. Remove single points of one fail. If you are trying to make any changes in that, it was not possible. Okay, that is removes a single point of a failure. And the next one is immutability, which means at any cost you cannot able to change or tamper your past data. Once it has been added, at any cost you cannot make any changes. Changes will not be allowed in the case of the blockchain network. That is what we call as an immutability. Then the third one is the transparency with the privacy. This is depending on the blockchain type. So based on the publicness as well as the privateness, that is going to be varying, depends upon the privacy as well as the transparency. Then the fault tolerance, this is survives the nodes failures and the attacks. It is going to be handled, so it will not allow any attacks is going to be taken over, as well as any failures cannot be caused in the case of your blockchain architecture. And the next one is the scalability. And in the case of the publicness, the scalability is being not allowed. But in the case of privateness, you will be have the extendable option. Okay, that is what the ability to handle the large volume of transactions. Then when you come to the primitive types, that is the basic cryptographic primitives which are all the fundamental building blocks which is used to secure the information in the computer systems and the blockchain networks. Okay, these primitives provide the essential functions such as confidentiality, integrity, authenticity, authentication, and the non-repudiations. Okay, the blockchain systems heavily relies on these primitives to ensure the secure and the tamper-proof transactions. Okay, then the major cryptographic primitives includes the hash functions, digital signature, the public key cryptographics, and then symmetric key cryptography, and the message authentication codes, that is MAC, as well as the Mercury, and also the zero knowledge proof, that is the advanced primitive concepts. When you talk about the hash functions, we have a function that takes the input and produces a fixed size of an output. Whatever the volume of data you are going to provide as an input, it is going to consider only as a fixed size of output. That is we call as a hash, or we can also call as a digest. Okay, now what are the characteristics we have inside that is, one is deterministic, which has the same input always gives the same output. Okay, when you give a same set of input, you will be getting same set of output. Any number of times if you are giving as input to this function, you will be getting only the same set of output which is you have already get it as a previously. So if there is any changes in the input, then automatically the output will also going to have some changes. Okay, that is what the deterministic. The second is a fixed output length, which is an example of SHA, that is secure hash algorithm 256 gives, we have 256 bits of an outputs. Okay, the next one is the collision resistance. It is difficult to find the two inputs as the same hash value. We cannot allow the same set of blocks inside the network. The same way, once a block has been created, once a block has been allowed in the network, at any cost, it will not allow any duplicate block of data in the network. The same way, that is the difficulty to find any inputs with the same hash values. Okay, you cannot find any duplicates as well as the same type of blocks inside the network. Then the next one is pre-imaging resistance, which is cannot reverse a hash to find the original data. Okay, you cannot reverse to hash to find the original data. Okay, the last one is avalanche effect, which is a small input changes give a drastical different output. What is that? If you are making any small changes in the block of data, the output of that thing you cannot find it in the same way with the existing process. So if you are changing even a one word, it will give you a different output. That is what we are saying. The avalanche effect is the small input changes gives the drastically the different outputs is going to be there. When you come to the digital signature is created using the public key cryptography and provides a secure method of verifying the authenticity as well as the integrity. The key properties of the
The key properties of the digital signatures are: one is the authenticity, that is verifies the senders, and the integrity ensures the messages wasn't changed. Okay, it is going to check whether if there is any changes has been there occurred or not. Okay, then there is the non-repudiations, the sender cannot deny sending. Okay, the example for this ECDSA, that is elliptical curve digital signature algorithm, which is used in the Bitcoin process. The next one is the public key cryptography, also called an asymmetric key. It has a public key. It has a public key for the encryption and also for the verification, and a private key is for the decryption as well as the signing in. So that is from one side, when the data is going to be encrypted, there will be a public key is going to be used. At the side, at the end, and the receiver side, the blocks once they are going to receive, it cannot be encrypted. It is going to be decrypted with the help of their private keys. And the next one is the uses of this is public key is the secure identity management, digital signatures, key exchanges, wallet generations in a blockchain. The symmetric key cryptographic uses the same key for the encryption as well as the decryption. It has the features of fast as well as efficient and uses for the bulk data encryption process. The example for this is symmetric key in cryptographic is AES, which is one of the most advanced mechanisms. Through that, it was directly inside to the blockchain ledger, and it is used to the system interact with the blockchain for the secure communication. When you come to the last, that is the message authentication code MAX, it is used to ensure the integrity as well as the authenticity of a message to messages using a shared secret key. The properties which has, that is the preventing tampers, lightweighted compared to the digital signature, and use the secure communication protocols. So this is the main process in the case of the existing mechanism. The sixth one is the Merkle tree. The Merkle tree is one of a binary tree of an hazards that allows the efficient verification of large volume of data sets. The last one, that is the zero knowledge proof, that is which is the advanced primitive. This method where one party proves something to another without revealing the actual information. Okay, so this is about the process of your primitive blockchain architecture and so on. So thank you so much.